Hello friends, how are you? In today's class, I want to discuss with you about vector. You all studied it in 10 plus 2 level. Now, as an undergraduate student, we want to see it from various angle of view. I will discuss one by one definitions of vector, types of vector, product of two vectors, physical significance of vector products, application of vector products in physics. Now the question is, what is vector? Let's see what it actually is. Most of you will say that scalar is a quantity which has magnitude only, just like temperature, density, mass, etc. Whereas vector is a quantity which has magnitude as well as direction. Velocity, torque, field, force are the examples of vector quantity. Remember, it must also obey the laws of vector addition also. You know the example of current which has magnitude and direction, but it does not satisfy the vector addition laws. There are other definitions also. Hope you are familiar with the term tensor. Can you remember the moment of inertia tensor? Actually, in an n-dimensional space, a tensor of rank p has n to the power p components. The moment of inertia tensor in 3 dimension, you all know, has 9 components: ixx, ixy, izz, etc. So it is a tensor of rank 2. From this point of view, we define scalar as it is a real number in 3 dimensional space. It is a tensor of rank 0. 3 to the power 0 is equals to 1. In 3 dimensional space, vector is specified by 3 real numbers. So it is a tensor of rank 1. 3 to the power 1 is equals to 3. There are other definitions also. Now, if we consider the rotation of axis in 3 dimension with respect to z axis, then the components of vector are related with the primed and unprimed coordinates as shown in figure. Ax prime is equals to ax cos phi plus ay sin phi. Ay prime equals to minus ax sin phi plus ay cos phi. Az prime is equals to az. From this point of view, scalar is a quantity which is invariant under rotation of the coordinate system in 3 dimension, whereas vector is a quantity whose components transforms under rotation as per the above relation in 3 dimensional space. Actually, vector is a geometric entity independent of the orientation of the reference frame. Now we want to define vector in an abstract way. Vectors are elements of vector space, say E, which satisfies some relations. U plus V is equals to V plus U, commutative law of vector addition. U plus V plus W is equals to U plus V plus W, associative law of vector addition. There are other relations also, where U and V are vectors, A and B are scalars. You will be wonder now by thinking, what is vector? If I cite an example from this angle, the set of all real solutions of the second order differential equation d square phi dx square plus omega square phi equals to 0 forms a linear vector space. Therefore the solutions are vectors. The complex numbers which forms the complex vector space are also vector. Lastly, we can say mathematically vector is a directed line segment. A is equals to A into A hat, where A is equals to PQ as shown in the figure is the magnitude of that vector and A hat is the unit vector. Remember, A hat is the increasing direction of A. So I hope you have got the answer. What is vector? I will explain each of them in proper place. Now, types of vectors. There are two types of vector. Polar vector, for example displacement, force, etc., and axial vector like angular velocity, torque, angular momentum, etc. Polar vectors are the quantities which change sign under inversion. That is, if we change x to minus x, y to minus y, and z to minus z, then r prime equals to minus r. Just displacement force, as I have told earlier. Whereas axial vector are the quantities which remains invariant under inversion. These are also called pseudo vector. In the figure we can see a cross b does not change sign under inversion. A changes to a prime, b changes to b prime under mirror reflection, you can observe it, but the magnitude and direction of c and c prime is invariant. So does angular momentum L is equals to r cross p. You can easily verify from the figure. Thus the cross product of two vectors gives pseudo vector. Here it must be mentioned that the dot product of two vectors is scalar and remains unchanged under mirror reflection. Such a scalar is called true scalar. Volume is a pseudo scalar. It changes sign under mirror reflection. Now the product of two vectors. There are two products. One is called dot product or scalar product, another is called cross product or vector product. The dot product. If we consider two vectors, A is equals to a1 I hat plus a2 j hat plus a3 k hat, and B is equals to b1 I hat plus b2 j hat plus b3 k hat, then A dot B is equals to a1 b1 plus a2 b2 plus a3 b3. The result is scalar. From another point of view, if the angle between them is theta, then A dot B is equals to AB cos theta, as shown in the figure. Now cross product or vector product. The two vectors A and B have components a1 I hat plus a2 j hat plus a3 k hat and b1 I hat plus b2 j hat plus b3 k hat respectively. Then A cross B is equals to matrix of I j k, a1 a2 a3 b1 b2 b3. The result is also vector. From another point of view, we can define cross product as two vectors A and B. If their angle between them is theta, then A cross B is equals to AB sin theta into n hat, where n hat is outward to the paper as shown in the figure. Now physical interpretation of vector products. The dot product. A dot B is equals to AB cos theta, we all know that. Say B is equals to 1 as shown in the figure. Then A dot B hat is equals to A cos theta, which is the projection of vector A along B hat. Now cross product. A cross B is equals to AB sin theta into n hat. Now if we want to find out the magnitude of A cross B, then mod of A cross B is equals to AB sin theta. We can write it as 2 into half into B into A sin theta. Now from the figure you can easily verify that it is equals to 2 into area of the triangle POQ is equals to area of the parallelogram POQR. Therefore we can say area is a vector quantity. Then I will ask you a question, what will be the direction of this area? Downward. Actually it depends in which way we have drawn the boundary. As shown in figure, in this case it is in the downward direction. Now application of vector products in physics. First, dot product. We all know work done. dw is equals to f dot dr is equals to f into magnitude of dr into cos theta as shown in the figure. Flux, you all know electric flux, magnetic flux. D phi is equals to E dot ds is equals to E into ds into cos theta. Now the applications of cross product. Moment of force, d tau. We know that from our 10+2 level, d tau is equals to force into perpendicular distance. So here from the figure, F into Pm is equals to F into Pq into sin theta. Therefore d tau is equals to Pq cross F. Now you can ask me that it may be F cross Pq, because F cross Pq is also is equals to F into Pq into sin theta. Actually here we want to satisfy the direction of the moment. Here the direction of d tau is out of the paper. That's why we have written d tau is equals to Pq cross F. Now angular velocity of rigid body. Forget about everything. From the figure we want to just find out what is omega cross r as shown in the figure. It is equals to omega into r into sin theta into n hat. Now omega cross r is equals to omega into r into sin theta into n hat, that is equals to omega into mp into n hat, that is equals to speed of p into n hat, that is equals to velocity of p in a direction perpendicular to the plane MOP. Therefore speed of the body, say rather velocity of the rigid body, v is equals to omega cross r. Here r is the position of the rigid body with respect to any arbitrary origin O. Remember, any arbitrary origin O. Now from 10+2 level we all know that the speed of a rigid body when it is rotating in a circular way, v is equals to omega into r. Then is there any difference? No. You can verify it if we verify it easily if we consider the two figures side by side. We have earlier said that velocity v is equals to omega cross r, where r was the position of the rigid body from any arbitrary origin, but here in scalar way we are defining v is equals to omega into r, where r is measured from the center of the circle. So is there any difference? No. When O and M coincides, they become same. Therefore I hope you are enjoying your study. Thank you.